Hello everyone, welcome back to this video series on SDTM programming with R for clinical SAS programmers. In this series, we will see how to implement key SDTM programming concepts using R. We will take a quick look at the SAS program for the same concept and then see in detail about the R program. Please note that the complete explanation of SAS program for this same concept is available in a separate playlist. I will leave the link for it in the description of this video. So in this video, we will see how to convert the raw date values to ISO 8601 format. So here on the left hand side of my screen, you see the SAS program that is used to convert the raw date values to ISO 8601 format and the equivalent of it in R on the right hand side of my screen. So let us now quickly take a look at the input data set and output that we are going to create. So here on my screen, if you see, so I have the input data and also the expected ISO date variable here on the column named AESTDTC. So I have U subs ID, AESTDAT raw, so which is the raw collected date value in a specific format, and the time value in a separate variable named AESTTM. So all we are interested here in is creating this AESTDTC variable. So here, let's take a quick look at the structure of AESTDAT raw and then AESTTM. So here we have the date value collected followed by 3-character month and followed by the year. So when a particular day or month is not known, so that is represented with the letters UNK. So for example, here on the third row, so this is unknown date in March 2009. And then here on the second row, we have unknown date and unknown month in the year 2008. So this is how the raw date values are collected or formatted. And then in the time variable, we have the time collected in 24-hour format. So when a hour or minute or second, when the full date is missing, so the time values are left null. And when we only know the hours, so it is collected, and when we know the minutes, so it is separated with a colon from the hours, and the hours are collected in 24-hour format. So we will have to use these two variables and create this variable called AESTDTC. So when we have only year collected, so we'll have to represent that year component, and when we have year and month, so we'll have to represent it in this way. And then along with that, so when we have both year and date and time also collected, so we will have to separate the time and date portions, so with a hyphen in between. So we will now quickly take a look at the SAS program that is used to generate this output. So what we are doing here is we are reading the input dataset named AE and creating a new dataset named AE01. So we are extracting the first component using scan function from AESTDAT raw, which correspond to the day of the month. So and then we are converting it into numeric using input function. And then we are converting that to extracted numeric day value into 2-character wide value using Z2 format using put function. And if it is missing, so we are setting it to a hyphen. So and then similarly you are using scan function and extracting the second word when space is delimiter, which corresponds to our month. We have seen that in the input data. So in the date variable, the second word when space is the delimiter is the month. So we are extracting that using scan function and then converting it into uppercase. And then as per ISO 8601 standard requirement, we'll have to represent each month with a 2-character wide string or digit. So we are converting that JAN to 01, Feb to 02, and so on till December 12. So as 12. And then if the month value is UNK or if it is missing, so we are setting it to hyphen. And then in the next thing, so we are extracting the third word from AESTDAT raw, which corresponds to the year value, and then storing it in a variable called stYear. So if stYear is null, so we are setting it to hyphen. And then now we have all the individual components converted into required format, and then we are concatenating those individual stYear, stMonth, and stDay, so with a hyphen in between. And then we are concatenating date component, which is already in ISO 8601 format in this variable AESTDATE, and then concatenating it with the time variable. But this time, so as we know that date and time values have to be separated with the delimiter t. So we are using the delimiter t as for the catex function as the first argument. And then so we will have the date value created here. So but in some cases, so that when the all the components are missing, we end up having five hyphens in the AESTDTC. So in those cases we are setting AESTDTC to null. So in some places where only year is known, we end up having four hyphens at the end. We do not want that last hyphen, so we are removing that using substr function. And then similarly, when we don't know only the day component, we will end up having two hyphens at the end of the created ISO date variable. So we are removing that last two hyphens again using substrn function. So this is the quick overview of SAS program to create ISO 8601 format. Now we will jump to the R program and then see this in detail. So let us have the R program opened on the left hand side, and then let us have the R dataset that we are going to create on the right hand side. So here we'll be mainly using the functions or majorly from the tidyverse package. So I have some other library calls, but again, so the main thing that we'll be using is tidyverse function or tidyverse library. So here I have my input dataset in a program called with the lesson name underscore data underscore R. I am calling that data program within this program to create the ISO 8601 format. So this is kind of equivalent to our %include statement in our SAS. So now we will see what this is doing. So here we are creating a new data set called AE01 by using the existing data set AE. So this gets created from this program which I have here on the top. So and then I am passing it on to the mutate function. So we know that mutate function can be used to create new variables in existing data set. So we are making use of word function on AESTDAT raw variable and extracting the first word. So and then converting it into numeric format. So this is word function is kind of equivalent to our scan function in SAS, and then we are extracting the first word, and then we have a function called as numeric. So this function is part of base R itself. So we are making use of that function to convert that extracted character day component as numeric. So in some places where we have the values like U and K, so we end up having a warning in the console window when we try to execute this R program. So when we know that we do not want to exactly convert that U and K values to is not convertible to an actual number, we can make use of suppress warnings function to suppress those warnings which get generated when trying to convert the values like U and K to number. So as numeric is equivalent to our input function, word function is equivalent to our scan function. So they are not true equivalent, but some of the features overlap and we'll be making use of those features only here. So, and then what we are doing here in the next step is we have created that numeric variable, and then when that numeric variable is not null, so we made use of Z2 format and put function to convert it into a 2-character wide string. So for the numbers from 1 to 9, so we want the leading 0 to be presented in the day component. So we are replicating that case here using strpad function. So here the first component for if else is it is equivalent to our if then else statement. So here what we are checking is we are checking for a condition. If that is true, so we are applying this statement to create stday variable, and else then we are assigning the value of hyphen to stday. So when stdyn dayn is not missing, so in R we represent the missing values with NA. So we can check whether a particular variable's value is missing or not using this is NA function. So when the day is not missing or not NA, so we are saying that use stdayn and convert it into a 2-character wide string, and when the width of the value in stdayn is not equivalent to 2 characters, so we are asking it to be padded with the number or the character 0. So this is kind of equivalent to our put of stdy and z2. So that's how we create stdy into two character wide string, and else if it is missing or na, then we are calling it, we are representing it with a hyphen. So we will take a quick look at the variables that are getting generated. So the first one is we are extracting the first word from AESTD raw, which corresponds to the day, and then converting it into numeric format. So in the places where UNK, if you see here, it has a missing value. And then, so in the next step, we have converted that extracted numeric component into a character wide of character string of two characters. So here if we see, if it is 15, so it is 1 5 22. But here if we see, when the number is from 1 to 9, we wanted to have a leading 0. So that's what we have achieved with this line of code. So stdy is equal to, so we now have the day component converted into the required format. So in the places where it is missing, so we are making it a hyphen. And then the next line of code, what we are trying to do here is extract the second word using again word function from AESTDAT raw. So which is equivalent to our month component. So when space is delimited, the second word corresponds to the month. So we are extracting the word, second word, and then converting it into uppercase. So str to upper is a function from stringer library of tidyverse itself. So this is equivalent to our uppercase function. So we are extracting the month and then converting it into uppercase and then storing it in a variable called stmonthc. And then we will make use of this stmonthc variable to create a two character month value in terms of digits. So for Jan it is 01, for Feb 02, and then all the way till December we are assigning the value of 12. So else if it is not, the value is not between like Jan to December, we are assigning a hyphen to it. Again, this syntax construct is called case when. So this is equivalent to our select when or a list of if then else clauses of SAS. So here, so case when, so what happens is it checks whether this particular condition is met or not. If this is met, none of these conditions are evaluated like in our select when or if then else series of if then else statements. So we are creating this stmonth variable into the required format as per expected ISO 8601 standard. So let us take a look at stmonthc here. If we see, we are extracting the second word and then converting it into uppercase. So here in the input data, we have all the letters in uppercase. So this doesn't look like much of processing has happened in terms of case conversion, but even if we had something like FEB in smaller case, so we would still get it as FEB because we have applied str to upper function. And then so we have created this variable called stmonth by converting it into two character wide string using a series of statements here using case when. And then whenever it is null or whenever it is not convertible a true month value, so we are setting it to hyphen. And then in the next line of code, what we are doing is extracting the third word, which corresponds to the year in AESTDAT raw. And then what we are doing on the next line, we are creating a variable called str1. So we are checking whether the str is UNK or whether str is missing. So either if it is UNK or if it is missing, so we are setting it to hyphen. So as described earlier, so in case of if then else, we check for a condition as the first argument, and then when it is true, we assign a particular value to the resulting variable. Otherwise, if it is false, so we set it to the second, the third argument goes into the variable. So here the condition that we are checking is whether the year is UNK or year is missing. If it is the case, so we are assigning hyphen. Otherwise, we are using the value from str and populating the str1. And here what we are doing is we are concatenating the year, month and day with a hyphen in between. This is kind of equivalent to catex function. One important difference is that catex by default ignores if the any of the components are missing and then do not concatenate that. But here in this case, this is kind of like you are using your pipe symbol concatenation with a hyphen in between these three variables. So we can still make use of strc to replicate kind of cates function or your pipe symbol concatenation, but with some limited number of times you can specify the delimiter in between those. So we have this argument called SEP. So for strc function of stringer package again. So we'll be making use of that. So we are now making use of the individual components which are already in the form of ISO8601 representation, and then concatenating them with a hyphen in between those three. So if we take a look at ISO AESTDAT variable, that which we are creating on this line, looks something like this. So here all three, ST year 1, ST month, and ST day are present. So the total of 5 hyphens are present here. So 3 correspond to the 3 components and 2 delimiters in between those two. And then similarly, we are concatenating all the other values. So and then, so we have the date in ISO 8601 format, at least in partial way. So we will have to do some post processing that we'll see in the next lines. So and then when we have the date, we also need to concatenate the time in to this date variable. So when we were seeing the input data, we were already discussing that the AESTTM is already collected in the required ISO 8601 format of 24-hour format. So no additional processing is needed for the time components. So we'll directly concatenate the AESTTM to the already created ISO 8601 representation of date value. Again, making use of strc function here. So, but here we are checking whether AESTTM is not missing. So if AESTTM is not missing, so we are making use of strc function to concatenate AEST date and AESTTM with a delimited t in between. So when the time is missing, we are only directly using the date component and assigning it to AEST DTC variable. So if you take a look at the AEST DTC variable, so this is kind of processed AEST DTC because we have 3 additional lines of code which is taking the same AEST DTC and converting it into the required notation. So when only day is present, what was happening is when the entire date is missing, so we end up having 5 hyphens based on our code processing. So if we have 5 hyphens in the date value, so we are trying to assign a missing value to the AEST DTC. Otherwise, we are using the existing AEST DTC. So here in the next line, so what we are trying to do here is, so when we only have the year present and neither time or the month or day is present, we end up having 4 hyphens at the end. So we are checking that. So str sub is a function is kind of equivalent to our sub str function in SAS. So we are checking if the last 4 characters. So this is kind of equivalent but not true equivalent. So this what this syntax is saying is, so when I say -4, it extracts the last 4 characters from AESTDTC variable here. So the last 4 characters are hyphens. So what I'm trying to do here is, so I'm again making use of str sub function. So we have a argument called parameter called end for this str sub function. So which takes the position till from first till which character you want the string. So what this is doing is, so you are extracting the letters from 1 to the 5th character from the end of the string. So from AESTDTC from first character to the 5th character from the end. So all of those are being extracted and then assigned to the AESTDTC variable. Otherwise, we are using the value from existing AESTDTC. And then when we only have uh, year and month present, we end up having 2 hyphens at the end in our processing. So in that case, what we are trying to do here is we are checking again. So if the last 2 characters in the created AESTDTC variable are hyphens, if that is the case, so we are extracting from first position to the uh, end of the string, but only to the third character because the last 2 characters are hyphens, so we do not want those last 2 characters. So we are extracting from first to the third character from the end. So we are achieving the end result here. So here if we see, so when we have all components are missing, we have the required AESTDTC as null. When we have only year present, that is being converted correctly. And then, so only year and month is known, so that is 2009-03. And then the date is full here, so 15th Feb 2010. And then here in this case, we only know the date and year, but the month is not known. So here in that case, so we still need to have the two delimiters, and also the missing month has to be represented with a hyphen in between. So we have that represented here. Similarly, for other cases when time is present. So one important thing to note here is the last record. We do not know the exact date, but we know the time. So here in that case, we will still have to represent all the date components with the hyphens, and then represent the time, so with a delimiter t, and then followed by the actual time collected. So this is how we can make use of R programming to replicate the conversion of ISO 8601 format. So what we will do now here is, so I also have the output data that is created from my SAS program here. I'll quickly open here it on the left hand side of my screen. So this is my output data set that is generated using SAS program, and on the right hand side I have my uh, output generated using R program. If we take a quick look at the values in AEST on all the 11 observation. So second observation 2008, and if we roughly take a look at the sixth observation, it is 2010-03-01. So if we take a look at the sixth observation here, the value is the same in AEST. And let us take a quick look at the 10th observation 2010 3-14 followed by 2253 with a T in between. So we have replicated the same concept using R program. So this is how we can make use of R programming to create ISO 8601 date time values. Thank you for watching and keep learning.